Ever wondered how the work of a man from the late 19th century could still significantly influence the field of geometry today? We're talking about none other than David Hilbert, whose work in geometry is considered to have had the most profound influence since the time of Euclid. Hilbert's journey into the world of geometry was one marked by rigorous examination and innovative thinking. He embarked on a systematic study of the axioms of Euclidean geometry, those fundamental truths that form the bedrock of our understanding of space and shape. But Hilbert didn't just rest on the laurels of Euclid. He pushed the envelope further, proposing a total of 21 axioms. His work was not just about adding to the existing body of knowledge, but about dissecting and understanding the very foundation of geometry. So, what are these axioms? They are assertions that are accepted as true without proof. They are the building blocks that allow us to construct the rest of geometric theory. Hilbert's 21 axioms expanded on Euclid's original set and laid down a more solid foundation for the field. These axioms touched on points and lines, the concept of betweenness, congruence, and the notion of parallels. But Hilbert's contribution didn't stop at proposing these axioms. He also delved into the significance of each axiom, analyzing their role and importance in the framework of geometry. His work shed new light on how these axioms interacted with each other and how they contributed to the broader understanding of geometry. Hilbert's work changed the way we perceive geometry. He brought a fresh perspective to the field, examining it with a critical eye and revamping it with his innovative thinking. His work is a testament to the power of questioning, examining, and reimagining, even in a field as old as geometry. So who was this man whose work continues to shape geometry as we know it? Let's delve into the life of David Hilbert. David Hilbert, born on January 23, 1862 in Wehlau, near Königsberg, Prussia, was not just a child prodigy, but a man who would become a mathematical legend. His father, Otto Hilbert, a county judge, and his mother, Maria Therese Erdmann, a lover of philosophy, astronomy, and prime numbers, provided a home where intellect was cherished. As a child, Hilbert lived a disciplined life under the strict supervision of his father, who believed in consistency and pattern. This discipline perhaps later influenced Hilbert's systematic approach towards mathematics. Despite the rigidity, the young Hilbert was nurtured in an environment that valued knowledge, an environment that would pave the way for his future in mathematics. Most children began their schooling at the age of 6, but David Hilbert was an exception. He began his formal education at the age of 8 at the Royal Friedrichskolleg, also known as the Collegium Fridericianum. Before this, it is believed that his mother, with her fascination for numbers, had been his first teacher. The Friedrichskolleg, though renowned as the best school in Königsberg, primarily focused on Latin and Greek, considering mathematics of lesser importance. This school's approach to learning was rote memorization, which was not Hilbert's forte. So it might surprise you to learn that this future mathematical genius did not excel in school. In September 1879, Hilbert transferred to the Wilhelm Gymnasium, a place that encouraged original thinking and had a greater emphasis on mathematics. Here, Hilbert found his footing and his academic performance improved across all subjects. His teachers noticed his lively interest and penetrating understanding of mathematics. He was not just learning, he was mastering the material and applying it with sureness and ingenuity. This early love for mathematics was not a fleeting childhood fascination. It was the start of a lifelong journey that would see Hilbert make significant strides in the world of mathematics and physics. Hilbert's interest and ingenuity in mathematics were evident from his school days, setting the stage for his future contributions to the field. In the autumn of 1880, Hilbert entered the University of Königsberg, marking the start of a journey that would revolutionize mathematics. At this prestigious institution, a young Hilbert immersed himself in a variety of mathematical disciplines. His first semester saw him tackling integral calculus, the theory of determinants, and the curvature of surfaces. Each of these subjects would later find a place in his extensive body of work. As was tradition in Germany at the time, Hilbert spent his second semester at Heidelberg, where he attended lectures by the renowned mathematician Lazarus Fuchs. Fuchs, known for his work in the theory of differential equations and functions, no doubt had a profound impact on Hilbert's mathematical philosophy. After his brief stint in Heidelberg, Hilbert returned to Königsberg for the start of the 1881-82 session. Here, he attended lectures on number theory and the theory of functions by Heinrich Weber. Weber's teachings, characterized by their depth and breadth, further expanded Hilbert's mathematical horizon. It's important to note that while Hilbert was a diligent student, he was not just passively absorbing information, he was always questioning, always analyzing. This active engagement with his studies is what set him apart from his peers. His probing mind was never satisfied with just the what. He needed to understand the why and the how. This inquisitive nature would later become a defining characteristic of his approach to mathematical research. As we trace Hilbert's academic journey, we can see how each step, each lecture, each theorem studied was a building block in the formation of one of the greatest mathematical minds of the 20th century. His university years were not just about acquiring knowledge, they were a time of exploration, of questioning, of laying the groundwork for the groundbreaking work he would later produce. In retrospect, Hilbert's time at the University of Königsberg was more than just an education. It was the crucible in which his mathematical prowess was forged. Little did he know his time at the University of Königsberg would be the foundation for his future groundbreaking work in mathematics. Hilbert was not only a mathematician, but also made significant contributions to the field of physics. His work spanned an array of areas, each marked by his unique insights and innovative thinking. In mathematics, one of his most notable contributions is his work on integral equations. This was a field of study that had been largely overlooked, but Hilbert recognized its potential. He developed a method for solving these equations, which was revolutionary at the time. His methods provided a way to approach problems that were previously considered unsolvable. This work laid the foundation for functional analysis, a key branch of modern mathematics. But Hilbert didn't stop there. He also made significant strides in the development of Hilbert spaces. These are abstract mathematical spaces that extend the methods of vector algebra and calculus from the two-dimensional Euclidean plane and three-dimensional space to spaces with any finite or infinite number of dimensions. Hilbert spaces are useful in mathematical analysis, quantum mechanics, and general relativity. In essence, Hilbert spaces offer a way to make the infinite comprehensible by providing a framework to work with infinite dimensional spaces. In the realm of physics, Hilbert's work on the mathematical foundations of quantum mechanics was transformative. His insights helped to shape the development of quantum mechanics, a field that has revolutionized our understanding of the physical world. Hilbert's contributions also extended to general relativity. In fact, he independently derived Einstein's field equations of general relativity using a variational principle. This work, along with his development of Hilbert spaces, greatly influenced the mathematical formulation of quantum mechanics and quantum field theory. In conclusion, Hilbert's work was groundbreaking and far-reaching. He redefined what was possible in mathematics and physics, pushing the boundaries of our understanding. His work has had a profound impact, not just within these fields, but across a wide range of scientific disciplines. Hilbert's work goes beyond mathematics and physics, influencing a broad range of scientific disciplines. David Hilbert passed away on February 14, 1943. But his legacy continues to inspire and influence mathematicians and scientists around the world. His work, particularly his significant contributions to geometry, remains as relevant today as it was during his time. Hilbert's work in geometry has had the most profound influence in that field since Euclid. His systematic study of the axioms of Euclidean geometry led him to propose 21 such axioms, a move that has fundamentally shaped the study and understanding of geometry. These axioms, even today, form the basis of many mathematical and scientific theories. Hilbert's influence, however, extends beyond geometry. Throughout his career, he made significant contributions to a wide range of fields within mathematics and physics. His work has played a crucial role in the development of quantum mechanics, and his theories have been instrumental in the advancement of mathematical physics. Throughout his life, Hilbert received numerous awards and honors in recognition of his contributions to the field. He was awarded the Bolyai Prize by the Hungarian Academy of Sciences, and he was also a member of the Royal Society, the French Academy of Sciences, and the American Philosophical Society, among others. Even posthumously, his work continues to be celebrated and recognized. The Hilbert Prize, named in his honor, is awarded every 4 years to a mathematician who has made outstanding contributions to the field. But perhaps the most significant testament to Hilbert's legacy is the ongoing study and exploration of his theories. His ideas continue to inspire new generations of mathematicians and scientists who are still delving into his work, expanding on his theories, and exploring the new avenues of thought that his work has opened up. David Hilbert, a man whose work continues to shape the world of geometry and beyond, truly left an indelible mark on the world of science.